Welcome to This Is My Architecture. I'm Matt from AWS. Today we're in New York City, and I'm joined by Scott from Zaloni. Thanks for joining.
Hey, I'm glad to be here.
So tell us about Zaloni.
So Zaloni delivers enterprise-level governance and data management software, and really our whole goal is to help our customers simplify their big data ecosystem. So we want them spending less time managing the ingest, defining security rules, defining data quality rules, and let their end users access high-quality information so that they can drive better business decisions.
That's great. So I spend a lot of time with customers building big data and analytics solutions on AWS in particular. So this is an area of interest to me. I'm glad we're talking about it today. I see a lot up here on the board. Today we're going to talk about one part of Zaloni's portfolio, ZDP. Is that right?
Right, the Zaloni Data Platform, yes. And so what our platform allows customers to do is manage hybrid environments. So traditionally we've seen a lot of customers start with their on-premise Hadoop cluster primarily.
Yeah.
And over time, they want to move more and more of their workloads to the cloud. And that may be recreating or moving some of their data lake to S3 buckets and using some of the AWS services to drive some of their analytics.
Okay. Yeah, everyone's talking about data lakes these days and how they want to build them. But making it happen is hard, right? So we see a lot of people putting their data on S3, but the reality is a lot of them have either on-premises data sources or they have, like you said, Hadoop clusters running on-premises as well. So I'm glad we're talking about a hybrid architecture today. So I guess we'll start with ZDP itself. Is this running on premises or is this running on EC2? What's happening there?
Yeah, so it can run on both, but for this purpose, let's say it's running on EC2.
Okay.
When it runs on EC2, we're using RDS for our metadata as well as Elasticsearch. And it doesn't take a really big instance to run our software because we're not really processing the data. We're pushing the processing into the various components.
It's kind of the brain in the middle of all
this.
That's right. Okay, so you said RDS. Is that RDS MySQL or another engine?
Yeah, it's MySQL today. We're looking at a few other engines to support as we move forward.
Great. Okay, so ZDP running on EC2, for example, or on premises, backed for the metadata by Elasticsearch and RDS. You have data sources over here. What type of data sources are you pulling in typically?
Sure. So it's probably data sources like relational databases that are on-premise, Oracle, Teradata, lots of different file formats. We support structured, unstructured, semi-structured types of information. It could also be cloud-based sources like Salesforce.com or Eloqua and those types of things.
Great. So what if my data is on S3? Will that work too?
Yeah, S3 can also be a data source to the data lake in addition to being the data lake itself, so we can catalog that as well.
Okay, so I guess one of the first features that we're talking about here, ZDP as kind of data cataloging your sources and where the data lives.
Yeah, cataloging and ingestion. So one of the things we want to do first is allow our customers to create connections to these various data sources, right? So maybe it's Oracle, maybe it's Salesforce and those types of things. When they create that connection, we'll catalog the technical metadata, the fields, the columns, the data types, and those types of different types of technical metadata that we want to use, but we also allow them to annotate, add business information. Maybe you're the business owner of a particular data set. And we may also want them to add data quality rules or governance rules on different types of tokenization or encryption that we want to run on individual fields as the data moves in or out of the data lake.
Okay, yeah, certainly with GDPR and all these other acronyms, sort of data governance and really policies is so important in big data and analytics these days. So does that imply that you are actually sort of maintaining and storing like a policy catalog, or I don't know how you'd call it over here?
Yes, so as part of the technical metadata, we also have operational and business metadata, and that's where those policies can be stored.
Got it.
So then what happens is once you've defined those policies and defined the connections, what you want to do is manage the ingestion. So in the case of, let's say we're moving the data from data sources to the on-premise data lake, we deploy what we call a data collection agent, DCA. And that agent's a lightweight agent that's watching for files and directories. When those files arrive, it pulls them in, it applies, it uses maybe Spark or MapReduce or whatever you have in your Hadoop cluster here to run our transformations, to apply the data quality rules, to apply the tokenization or encryption rules from a governance perspective.
Okay, so if I'm a customer and I'm running, for example, a Cloudera cluster on premises, I have my data collection agent running that will not only sort of apply the policies or tell the data where it is, but also actually move the data.
That's right.
And so is it doing parallelization, parallel writes to and from the cluster?
Yeah, I mean, from a big data perspective, you have to have the parallel writes to be able to meet the types of performance needs and volume needs that you have. So we have customers both on premises and S3 that are moving dozens of terabytes a day in and out of their data lake.
Okay, so that has to be quick.
Right.
Okay, so that's on premises. What about moving data to and from S3?
Right, so there's a couple ways we can facilitate that. First and foremost, if you want to create a connection as the target from the data sources to S3, we actually run workflows that use the S3 copy commands.
Yeah.
Once they use the S3 copy commands, they're going to move the data into an S3 bucket. Let's say that's the raw zone where you're dumping your sort of unfiltered raw data.
Yeah.
But also as part of those workflows, we can spin up EMR clusters. So we can have a manifest file that says we're going to spin up a couple nodes from an EMR cluster perspective. We'll deploy the microservices for Hive, for MapReduce, and for Spark. And then customers can run the same data quality rules, the same tokenization and encryption rules that they did on premise in EMR, and then load the data into a more refined zone, let's say within an S3 bucket. And what's great about that is they define it once based on the entity, whether the target is on premise or S3, they're using the same rules.
So that's actually really interesting what you said, because in this hybrid architecture, not only is this a data catalog, but it's also a catalog of sort of data transformation that you could do in EMR or on premises, for example. It's sort of platform agnostic.
Yeah, and it's platform agnostic's one thing that we want to be, and it also allows a lot of reuse, right? So we want customers to be able to reuse this information back and forth, and it can have cost benefits when they move to S3 because we can spin up the cluster and let's say run it for a few hours as part of the processing for one file, and then we can shut it down, and they're not paying, ongoing costs for keeping your cluster running.
Yeah, okay, that makes a lot of sense. So this could be an ephemeral EMR cluster, in other words, and so your data is residing on S3, but you're paying pennies to store it. Well, if it's multiple terabytes, maybe more than pennies, but not much. But you can spin up the clusters, wipe them out when you're done. But in practice, with your customers, are you seeing customers keep the clusters up, or are you seeing them truly use ephemeral clusters?
Yeah, so it's a really good question. I thought we would see them spin them up and spin them down more often, but generally what happens is they're spinning up the clusters for maybe daily processing or weekly processing, and then they'll shut them down. So we have a workflow now that actually registers the cluster with ZDP, so it becomes an actual connection that we can make from ZDP so other users can use it. We're not having to constantly run the same manifest to bring the clusters up and down.
So that's interesting. So in addition to being a data catalog and also a catalog of transformations like we were discussing, it's also a catalog of resources you have to run jobs.
Yep, absolutely. And one other point I think we didn't mention, regardless of whether we're moving the data from data sources to on-premise or moving it ultimately to S3, we are capturing lineage as the data moves from wherever the source is to the target and any transformations that we're running. And that's really important from a catalog perspective because ultimately you want business users to be able to query the catalog, you want to find information about customer data, and you want to see where did that customer data come from, who transformed it, and ultimately who has access to it as we move forward.
So that access point is important and actually ties back to lineage as well. So I see you have Athena and RedShift, which I imagine are options that you provide to customers to sort of analyze or manipulate the data. But how do you control, who can access this data or who can access what parts of the data?
Right, so we generally recommend that our customers manage their data lake via zones. So you might have a raw zone, a refined zone, and a trusted zone, and you may set up either IAM or directory service policies from Active Directory on which users have access to which data in each zone. And then from a tokenization or encryption perspective, we can encrypt the data on read. We can also have server-side encryption for data at rest. But let's say you're going to read some sort of SSN information or credit card information, our tokenization policies can make sure that you can only see the masked version or the tokenized version of that to use it for aggregation and analytics, but you don't want to expose any customer information.
And these zones in S3, are they represented or how are they isolated at the bucket level or using bucket policies?
Yeah, it's generally bucket policies or directories within the buckets, but usually it's each zone will be its own bucket.
Yeah.
And we define that as a metadata object here, so you can also create policies around who has access to the various zones. Also, we're starting to work towards building data quality policies. So before the data can move to the refined or the trusted zone for analytics, we want to have a certain data quality threshold met.
Okay, and that access and authorization, you mentioned IAM. Can you also use directory services integrated with Active Directory, et cetera, to manage that?
Yeah, absolutely. That's mostly what our customers use is AWS and Active Directory integration.
Great, so that way you have zone level and user level sort of segregation, and they can decide how to actually tie back to their authentication backend.
Yep.
Okay, so I understand how you're segregating via zones, how that's represented in S3. It all makes sense. But then these policies, how you're moving the data around, who can access what, where is that actually getting stored, and how is that working?
Sure. So each table or file that we manage, we call an entity. And each entity can have various policies on which zone it belongs to, who has access to it, and so forth. And one of the interesting things we can do from a data lifecycle perspective is many customers are going to continue to use their on-premise environment in perpetuity. And they may want to move data once it gets into a certain zone on-premise to a particular bucket in S3 for maybe use within RedShift. So we can actually set a data lifecycle management policy that will automate the movement of the data from the on-premise environment into S3, and even potentially using the copy commands from S3 into RedShift to make the data available to the analysts.
Great, okay, that makes a lot of sense. So I like how you're handling data movement and how you're doing it through a schedule and policy base. I like how you're handling data access and tiering the data and using zones, how you're providing access to different services. You're basically service agnostic in addition to platform agnostic, how you can handle different data sources, the parallelization, all the modern things you need to do for big data workflows. It really solves a lot of problems that I see at customers when they're working with analytics workloads at scale.
Yep.
So thanks for sharing it with us.
Awesome, thank you.
And thanks for watching. This is My Architecture.